Hi everyone, this is Matt. Today I will talk about another solution of a problem on Leetcode. And this problem is reorder list, number 143. So let's look at the problem description. So given a linked list like this, L0, L1 to Ln minus 1 to Ln, and reorder it to L0, Ln, L1, Ln minus 1, and L2, Ln minus 2. So, uh, in another word, you try to reorder this linked list by uh, combine the first and the last element together, and you keep doing it. Uh, Finally, you will reach the middle of the linked list. If the linked list has all the number of elements, you will finally only one element. There is only one element left in the linked list. So you append this uh, last element, which is the element in just right in the middle of the original linked list. Uh, it will be the last element of the new linked list. So there is a requirement for these problems, which is you cannot change the volumes in this linked list, but you can change the pointers itself. So you can change the loads. You can change the loads. So here is my solution. These solutions I use extra ON space to achieve to solve it. But I believe you can use O1 space to solve this problem. But I'm going to share you these solutions with extra space because it's quite simple, because it's very simple and easy to implement. Okay, let's look at the code. First, I check if this linked list has less than 2 elements or not. If the number of elements in this linked list is smaller than 2, we don't need to do anything. We don't need to reorder this linked list. We just return what the linked list looks like before. So this is simple. Later, I define a double Q structure vector. So this double Q vector is very is the trick here. I think it's very useful for this problem because you kind of lead to um, get the first and last elements of the linked list um, in random access. You need to randomly access the first and last element. So for regular vector or stack, you cannot do this efficiently. However, in C++, you have a double queue data structures which provides such convenient operations. You can like fetch the first element and the last element very efficiently. So this is double queue, and but before I use this double queue, I need to traverse this linked list once, so I can store each element in this double queue. So this while loop just is doing that since just copy the element in the linked list into the double queue. And next, what you need to do is very simple. So okay, this code is not needed. So next, you define two pointers, which is the current pointer points to the current nodes of the new linked list, and the new head is the new head of the new linked list you created later. So next, you only need to write a while loop. You check if is there any element left in the double queue or not. If it's empty, then we finish it. We finish the reordering of the linked list. So first we get the element from the front. I get the element from the beginning of the linked list. So you just call this function. DQ front is just get the first element or in the beginning of the linked list, and after you get the first element in the double queue, you have to pop it out, pop it out. So then the size of the double queue will reduce 1. Okay, and of course, because you need to remember the head of the new linked list, so you have these if conditions to check if the new head is non-value or not. So if it is non-value, you have to assign it to the first element you get from a double queue, right? And you also need to update the current pointer, which points to the current um, node you append to the new linked list, because um, when you get the next node, you have to link the previous node to current node, right? So if the new node is not now, it means okay, there is already a node appended to the new linked list. So you need to the current node must point to the new new node. So and you update the new node to the you update the current node pointer to the new node, right? Okay, so this part is to get an element from the beginning of the linked list. So beginning of the double queue. And the second if condition, so after you get one element from the double queue, it is possible that this double queue will be empty. So you have to you need to use this if condition to check if it is already empty or not. Otherwise, you will get an error of fetch some things in an empty double queue. So and in the if condition, you get an element at the end of the double queue. So you use this back function, and after you get this element from the back, and you just pop it out from the double queue, and then the size of the double queue reduce 1. Okay, and similarly, you update the current pointer. Um, Current pointer's next pointer points to the new node you get from the double queue, and then you update the current pointer to the new node you get from the double queue. All right. So in this while loop, you get one element uh, from the beginning of the double queue, and then you get one element from the back of the double queue until this double queue becomes empty. This is exactly what what you need to do for this problem. Okay, and okay, next next you only need to update the head to this input head to the new head. Then you are done. You just return just return void value, because this function does not require you to return anything, but you have to assign this new head to this input head pointer, because when you run these programs on the background, I think they need this pointer. Otherwise, you will get error. You will get an error. So, and this assign the current legs to none. What does this line? What does this code mean? So it means like current node actually is the last node in the new linked list. All right. So it's actually the last element in the new linked list, and this element it originally located at the middle of the linked list. Okay, so the next pointer of this current node does not point to a long value. It points to some other element in the linked list. So if you do not write this code, you will get time limit error, because when the online judge platform check your program, they will this linked list actually has a cycle in it, because this last element points to a previous node in the linked list. So there it contains a cycle in it. So they will keep find the next value when they check this program, and you will get time limit error, even if this code perfectly solve this problem. So you have to assign the next pointer of the last element to long value. Then the platform, when they check your code, it will it will have no problem. Okay, so this code is very important. And okay, that's the solution to the problems 143 reorder list. Thank you.